Chapter 1. Survival Water Preparedness. The Parker family lives in a suburb of Columbus, Ohio, where Robert and his wife Evelyn raise their 10-year-old son Evan and 8-year-old daughter Alicia. They have a young golden retriever named Sparky and an old cat named Ginger. Robert works as a salesman at a local car dealership, and Evelyn works part-time as a substitute teacher. The family enjoys Saturday evening barbecues with their neighbors and attends church on Sunday. By these accounts, the Parkers are a solid example of a successful American family. But when a major power outage occurs in Columbus and affects the surrounding areas, the Parkers suddenly find themselves without electricity, and their water stops running. Evelyn frantically searches their refrigerator and pantry, but realizes they only have a few water bottles. When Evan asks his father what they will do, Robert realizes that he has no idea what they will do to mitigate the cessation of seemingly limitless clean water in their home. Thankfully, the power returns a few days later, but Robert and Evelyn are shaken by the experience. They can't help but ask themselves, what if the power goes out for a much longer period next time, or even worse, remains off? The realization slowly dawns upon the couple that maybe so-called doomsday preppers aren't so crazy after all. Most people, like the Parkers, are not prepared. According to FEMA, only 39% of individuals have a basic emergency plan, highlighting a significant gap in preparedness among the general population. And, like I mentioned in the introduction, having a solid plan for storing and collecting more fresh drinking water must be one of the core elements of every emergency plan. Do you ever wonder why scientists spend time searching for water on other planets? Water is essential to life. Even minute traces of it on another planet can indicate that life could or did exist there. Water is also one of the most abundant molecules in living cells and one of the most critical to life as we know it. That's why, in biology, water is one of the most essential substances you'll learn about. Approximately 60% to 70% of your body is water. The essence of life. Let's put it this way. Life would not exist without water. It is the most abundant resource on Earth, and all life forms depend on it for survival. Just think about all the things you need water for daily: hydration, cooking, cleaning, hygiene, temperature regulation, and much more. An interesting fact about Earth is that it is often called the blue planet. This is because about 71% of the Earth's surface is covered by water, which plays a significant role in creating its blue appearance when viewed from outer space. Water is also constantly moving through Earth. Water is carried through and around the Earth in a process called the hydrological cycle, during which it can exist in 3 different forms: liquid, solid, and vapor. Liquid water forms are rivers and oceans, thus giving the planet its blue appearance, and it can also be accessed underground via water wells. Over 97% of Earth's total water is salt water, and less than 3% is fresh water. Of that fresh water, the overwhelming majority, 70% plus, is in the form of ice in the polar regions and other icy regions worldwide. Nearly 30% of the fresh water is underground as groundwater, and less than 0.5% is in lakes and rivers. Contrary to what most people think, the amount of water on Earth does not change. Even though it appears that we are losing water when it evaporates, the water is being transformed from liquid into a new form, vapor, to continue the hydrological cycle. The hydrological cycle is as follows. Evaporation. Evaporation is the process by which water transitions from the Earth's surface into the atmosphere, transforming from liquid to vapor. The sun initiates this phenomenon, which provides the necessary heat and energy and occurs regularly. Additionally, plants contribute to this process through transpiration, releasing water into the atmosphere. The ocean is also a constant source of evaporation. Transportation. The next stage is transportation, where water is carried through the atmosphere to different world regions. This daily occurrence is visible in the movement of clouds, which are propelled by winds that are, in turn, generated by phenomena such as sea breezes and the sun's heat, which also influence wind patterns. Condensation. Interestingly, Most water is transported as invisible vapor. Clouds become visible when water vapor condenses, forming tiny water droplets that cluster to create the clouds we observe in the air. Precipitation. Water then returns to the earth in the form of precipitation. When clouds of water droplets encounter cool air, these droplets coalesce and descend to the Earth's surface as rain or snow. This phase completes the cycle, and the process begins anew with evaporation. A large portion of precipitation, whether rain or snow, permeates the ground and becomes the appropriately named groundwater. Essentially, groundwater is water that resides beneath the Earth's surface, either within the soil or between layers of rock and clay. Some hidden groundwater is accessible through water wells. As water infiltrates the ground, it consistently moves downward until it encounters an impermeable barrier, such as a layer of rock. The water's movement then shifts laterally. These subterranean pathways of lateral water movements are commonly referred to as aquifers. Aquifers allow the water to travel back to the surface via springs, or openings in the ground, and form streams, rivers, ponds, and lakes. We'll discuss the different bodies and sources of water in Chapter 2, but hopefully you now have a good idea of how water moves throughout the earth. The key thing to remember is that water is always in motion and shifting from one state to another. The lifeline of survival. Water is one of 6 essential nutrients the human body needs to survive. The other 5 are carbohydrates, minerals, vitamins, proteins, and fats. Among other things, your body needs water to regulate your internal body temperature, moisten the tissues in your eyes, nose, and mouth, protect your body organs and tissues, carry nutrients, electrolyte minerals, and oxygen to your cells, lubricate your joints, lessen the burden on your kidneys and liver by flushing out waste products, dissolve minerals and nutrients to make them accessible to your body. The amount of water you need to drink daily depends on several factors, including age, weight, how hot it is outside, and how much physical exertion you experience. For instance, a 200-pound male spending all day working hard in 90-degree heat Fahrenheit will require more water than a 110-pound female staying home and reading a book all day in air conditioning. But as a rule, the body needs, at a minimum, around half of a gallon, or 8 8-ounce glasses of water per day to function normally. Ideally, you should drink these 8-ounce glasses of water throughout the day, such as 1 glass every 2 hours. Drinking a full gallon is preferable for some people, including those constantly exerting themselves. Contrary to what many believe, drinking slightly warmer water is healthier for your body than ice-cold water. As one who has spent years in a rainforest jungle's searing heat and pervasive humidity, I'll be the first to acknowledge that there's nothing more refreshing than drinking a glass of ice water or cool coconut water when you're thirsty. But the reality is that your body can absorb lukewarm water faster than cold water and will therefore hydrate you sooner. This is why your body should drink mildly warm water while hiking or working hard outside, even if it doesn't taste nourishing or refreshing. Speaking of which, your body naturally loses water during periods of exertion. Thus, it's essential to replenish your body with more water throughout the day. You lose water via perspiring, breathing, urinating, and bowel movements. On average, your body will lose half a gallon of water or more per day in this manner, so it's essential to take at least half a gallon per day, as previously advised. In a grid-down disaster scenario, you will spend much of your time each day exerting yourself. An emergency survival situation would never be the time to kick back and relax. In such scenarios, you'd spend much time tending to your property, checking your security measures, preparing food, heading out into the woods to hunt or forage for food, and so on. As a result, your body will likely consume calories and lose water faster each day in a grid-down disaster than it does now. Also, as a rule, the body can last for around 3 days without any water intake. In some instances, however, it may be even less. For example, If you constantly exert yourself day after day under the hot sun without water intake, you would most likely not make it 3 days without rehydrating. Your body becomes dehydrated when it receives less water than it needs to function correctly. When you get severely dehydrated, your cells start to shrink, your kidneys become damaged, you'll notice more pain in your joints and ligaments, and in extreme cases, your brain could even begin to swell. When these things start to happen, you'll feel increasing headaches, physical exhaustion, and mental confusion. These effects can happen in as little as only 1 day without water, which is why it's so important to ensure that your body is sufficiently rehydrated every single day. In addition to the effects indicated above, the easiest way to check if you are dehydrated is to pay attention to the color of your urine. Yellowish urine, similar to lemonade, indicates proper hydration. In contrast, darker colored urine, brown or yellow-brown color, strongly indicates that you are, or close to being, dehydrated. The point I'm making here is that when it comes to water storage, which I'll cover in depth later in this book, you need to make sure you have enough water set aside so that each family member can remain fully hydrated for the duration of a disaster. Failing to do so will result in your family feeling the onset symptoms of dehydration, which can accelerate when everyone is physically exerting themselves more than usual on tasks related to survival. For example, let's say you have a family of 4 and want to set aside enough water to last your family for a month. At a minimum, you would need 120 gallons of drinking water stored, and even that figure may be too low when you consider other factors that I'll present in Chapter 5, Long-Term Water Storage. This leads us to our next subject, self-sufficiency in water sourcing. Right now, you have a pretty good idea of how water circulates throughout the earth and how important it is for your body. It truly is a lifeline for your survival. Next, let's consider, what is self-sufficiency? To answer that question, we should first consider sufficiency. Material sufficiency means having enough for your and your family's overall well-being. A big part of sufficiency is knowing how much is enough. You might be surprised by how little you truly need if you can reduce your material needs. This is one of the pleasantly surprising life lessons my wife and I learned when we survived and thrived in our remote off-grid village with only a dozen medium boxes containing our supplies. Trimming the fat, as I called it, of most of our unnecessary material dependencies was time-reclaiming, mentally decluttering, emotionally relieving, and spiritually refreshing. Self-sufficiency is the ability to facilitate your own survival without external assistance. It is a lifestyle that generates confidence in your ability to thrive using your resources. Sourcing your food, water, shelter, and energy are some of the basic requirements of becoming self-sufficient. Some of the common goals of preppers are becoming self-sufficient, adequately providing for their family's basic needs, and generously sharing with their neighbors. For some, the term prepper conjures images of individuals donned in hazmat suits, anticipating an apocalyptic event when the defecation hits the oscillator from the confines of a fortified underground bunker. This stereotype, however, has perpetrated a stigma around prepping, one that initially dissuades some folks from understanding and embracing it. During the younger years of our lives, we had dismissed prepping as being alarmist or eccentric at best. For a substantial part of my life, I dismissed preppers as eccentric and their practices as overkill. Then, following several years of actively engaging in prepping before and during long-term jungle living, our perspective evolved and expanded. Being a prepper does not mean obsessively revolving your life around doomsday scenarios, nor does it require adopting an irrational and paranoid demeanor that is sometimes portrayed in prepping-themed shows and apocalyptic movies. Contrary to Hollywood stereotyping, being a prepper is about developing a resilient mindset and formulating practical plans to prepare for possible disaster scenarios. Essentially, being self-sufficient as a prepper for your family's water requirements requires that you have a substantial supply of fresh drinking water to last you and your family for an extended period of your choosing. Have a means to harvest and collect more fresh water. Have means to filter and purify the water you collect to make it clean and safe to drink. In other words, I advise against being solely and entirely dependent on your local municipal water source to provide potable water for you and your family. To ensure your family's resilience during crises and to bring you peace of mind, you should be able to gather, filter, and purify all of the water you need without being dependent on the water that comes from your local utility company and out of your kitchen faucet or outdoor spigot. The foundations of water preparedness. If you haven't already done so, I would encourage you to start considering how to collect and store water without dependence on the power grid and/or your existing traditional water supply systems. The following is a checklist you can follow to ensure that your bases are covered. Have a solid water storage system in place. If you want to store a lot of water to prepare for a natural or civil disaster, you'll need plenty of storage containers and knowledge of how to store water in those containers for an extended period safely. I'll cover how to store water properly in Chapter 5. Learn about your local natural water sources. Research nearby freshwater sources such as lakes, rivers, streams, and ponds. While living on a property with a freshwater source is advantageous, knowing the location of accessible freshwater within walking or driving distance would be beneficial. Establish a means to harvest rainwater. Install a rainwater catchment system to capture precipitation efficiently. This involves collecting rainwater for potential use, preventing the wastage of this natural resource. You would be surprised by how much water you can collect via rainfall. In Chapter 4, I'll teach you how to build different kinds of rainwater harvesting systems. Install a water well. If you confirm that your property is conducive, consider installing a water well. Wells can provide a consistent and reliable source of groundwater, which I also don't believe you should allow to go to waste, just like rainwater. A water well is one of the most reliable, replenishable water sources. Diversify your water collection techniques. Besides collecting rainwater, you could learn about other water collection methods. These can include constructing solar stills, using transpiration bags, collecting dew, and digging for water in the ground. Becoming familiar with these methods enhances your adaptability in different situations. Chapters 2, 4, and 6 will discuss different water collection methods. Now you can rate yourself to see how well prepared you are regarding self-sufficiency and water storage. If you haven't checked off each of the projects described above, you could commit right now to making the design and preparations to fill those gaps. Bridging the preparedness gap. If, based on the above checklist, you self-assess that you're not thoroughly prepared for potable water storage, that's okay. After all, one of the reasons you're reading this book is to learn some options and methods for shoring up your water systems and resources. For the remainder of this book, I will provide you with all of the information you need so you can check off each of the water sourcing methods listed above. Applying everything you are about to learn in this book will be an ongoing process that could take you weeks, if not months, to complete. But for now, here's what you can do to get started today. Evaluate your current water supplies. Check your current water supplies at home, including stored water in containers. Ensure containers are food grade and in good condition. Ask yourself, if the grid went down today and the water stopped running, would we have enough water to last us over the next several weeks? Identify and utilize indoor water sources. Familiarize yourself with indoor sources in emergencies, such as your freezer ice and water stored in pipes. If you expect the power to be off for an extended period, you could promptly plug up all your sinks and bathtubs and fill them with water, to drain and use as much water from the pipes as possible. Identify local freshwater sources. Research and map nearby freshwater sources, like rivers, lakes, or ponds. Identify locations within walking or driving distance for potential water access. Calculate the daily water needs of your family. Calculate your family's daily water needs based on factors like age, weight, climate, and physical activity. Then start thinking about where you can find the space to store that volume of water, whether in your basement, garage, or outside, covered. Now that we understand the importance of being prepared and assessing our current state of water preparedness, let's examine the various water sources around us and how to collect it effectively.
To keep listening to this audiobook, I've left you a link in the description so you can do it, at no cost thanks to Audible's 30-day free trial.